share your experience. Sounds challenging.
Yeah, it's
You get
recording now and
some.
it's
Oh,
fine.
it's recording now.
Yeah, if it's up to
Gee.
you. But I can tell you that it was just fortunate because like a Google recruiter just approached me. They saw my LinkedIn because I got interview offers from Facebook and Google, and they
Oh,
both just
nice.
came through LinkedIn. They saw my profile. I add pretty much every recruiter I meet, on LinkedIn, and they came across my profile and liked what I saw on my LinkedIn, and from there they just reached out. I was like, "Hey, would you be interested?" Or they get my email from my LinkedIn, and they just email me like, "Hey, I'm a recruiter from software company. Would you be interested in applying? We happen to have some roles, in California." And like, is there a time to chat? Because they don't just like you don't just apply. You apply. They talk to you, they ask if you'd be interested in working for the tech company because it's like more difficult than your typical job. But they ask your background, what languages you know. But yeah, as far as like how they reached out, it was just happen. It was happenstance basically. They just saw my profile. They're like, you should apply, and then when you apply for your profile, I'll tell you what's needed, and I can schedule you an interview and tell you how to prepare.
Oh, so the recruiters approach you,
Yes. So
get
I mean,
the interview.
either way, you have to apply. It's easier if you're in their system. So you go to the careers page for Facebook, Google, Amazon, and apply, and then from there, it's much easier for a recruiter to find you within the database. And then at the same time, if they happen to, because even if they find you like on LinkedIn, they're going to see if you're already in the database, and from there, it's usually easier to uh, if you've never interviewed, it's usually easier. And then if you have interviewed, depending on how good or bad the interview was, you're more likely to get asked back to interview again.
So you
So, what?
applied. Sorry, you go ahead. I will.
Oh yeah, no problem. No, I was saying so. Like, what position do you apply for? Was it like front end, back end, or was it maybe what full stack development? And how was the interview process like? Yeah.
So for Facebook, it was like just software engineer. So it was like basically
Oh,
full
okay.
stack. Um, Only went through one round with them. I was like super scared, like chickened out, and it was like and, but yeah, that one was full stack, and then Google was front end specifically, so it was a little different. So like for the front end one, instead of like all algorithm like problems, one of them was like a front end specific problem where you had to do something with algorithms uh, to like do something on the front end. Not like a crazy algorithm, but like you had to create a function that like um, create a function that mixes two things together and then puts it on the screen. Or some people like they got asked like a specific framework question. If they said they knew a framework, they'll be like make a form in a using React or something. But mine wasn't that like that. And front end, I guess, is technically, at least seemed like algorithm wise, an easier path. Is the it's less complicated algorithms compared to a back end engineer, but it's still algorithms, and yeah, it still helps if you know all those kinds of data structures because within those companies you can kind of move around and be anywhere at any time. Like some people interviewed as back end and ended up front end, and you put on a front end team, and then vice versa. So it helps to just know as much as possible, and like the more they can use you, I guess.
Yes, the questions are very similar to Algo Expert.
Um, cause, cause before my Google interview, I actually like hit up Clement on LinkedIn for his advice, and there wasn't much he could tell me, and therefore there's not much I could tell you, but I can say that like the techniques, the questions are similar. I'm not allowed to say the questions, but I can say the techniques to solve the questions in Algo Expert are some of the techniques I wish I could have remembered in my interview with Google. Like some of these pointer systems for example, I wish I had a better knowledge of it in my head for Google interview, because the first interview question I had, it would have been so much better to use pointers rather than use like a nested for loop, because it was like my first interview. I wasn't warmed up. I was nervous, you know. So, for example, like this two num sum would have been, or three num sum would have been very helpful.
That's
With
great.
like practicing this.
Power. Yeah. Yeah.
Because I was thinking about it when I was listening us go over the problem. I was like, man, why didn't I just use pointers? I was so stupid. But it's over now, so it's easier to think like after the fact. Not when you're on a timer. You're just like, I know there's something I should be doing, but I can't think of how. So I'm just gonna solve it, and then maybe I'll figure it out by the end.
Okay.
Oh yeah.
Sounds good. You have any more questions about interviews, our, or we just gonna start our algorithm question?
No question. I mean, yeah, well, we can dive into the problem. No.
Okay. Yeah. Okay. So next time we will ask you more, David. Okay. Okay. So we're gonna today. Our question is this one. Can you please read the question, Devin?
Uh, oh yeah. Wait, we are. Make sure my cursor. So we're
Um,
reading here,
yes.
here.
Line 3. Yeah.
Okay. Write a function that takes in a non-empty array of distinct integers and an integer, and an integer representing a target sum. The function should find all triplets in the array that sum up to the target sum and return a two-dimensional array of all the triplets. The numbers in each triplet. Oh goodness, where'd it go? The numbers in each triplet should be ordered in ascending order, and the triplets themselves should be ordered in ascending order with respect to the numbers they hold.
And one more. Line
Oh
6. Yeah.
If no three numbers sum up to the target sum, the function should return an empty array.
Yeah. So this is the sample input array we got, and the target sum is 0. And this is the sample output. Does anybody have questions about the prompt? Like you don't understand what is the question?
So the main idea is we want to find three numbers, or find triplets of numbers that are equal to the target sum, and we want to make sure those triplet numbers are in the correct order, and there could be multiple triplets, right? Where those three numbers could equal the target sum, right? So like the example I think is saying that we have some arbitrary length of numbers, and then we just go through the array, find what three distinct numbers that equal to the sum, and those three distinct numbers should be in a respective I'm sorry, in order, and with respect to the numbers they hold. So if we have like 2, 6, and -8, it should be -8, 2, and 6, and -8, 3, 5, 7. Okay. Yeah, I think okay. No, I think I understood it. Yeah.
Okay. So I can walk through this problem today. I like a pointer system. so the
Okay.
so we can this is very similar to the two noun some but more complicated. You remember we can use three for loops for this question, but we don't want to use it because it's not an optimized solution. Uh, that will make your to be like the Qbert. So and we don't want to use hash table for this one either because use too much space. So I just gonna use pointer system to walk through this question. So okay, now I am in tab. No dot md tab. Can you guys see my screen? Um,
Yes, I can.
okay, okay, so that one.
Dot empty tab. Yeah, I can see.
Okay, so I gonna this is the last time question. I gonna delete that one. I was just you know I try to be okay. So this is the pointer system. Um, since last time we know the point system of in all the point system, basically we need to initiate a left pointer and a right pointer. In order to make the pointer system work, we first need to sort the array. So I will say step one, sort array. So make sure it's in ascending order. So that will be -8 and -6, 1, 2, 3, 5, 6, and 12. Can you guys help me check see see
Or is it in the correct order?
yeah correct order and the same value so I don't make a mistake. I think it
Yeah, I think you're missing. Yeah, I think. Hold
will
on.
check.
Hold on.
Yeah.
-8, -6, 1, 2, 3, 5, 6, 12. Yeah, yeah, it looks right to me. So
I'm literally just
Okay.
gonna put an enter in the console and sort it and see what happens.
yeah, if you want to do that too. Yeah.
Yeah. Okay. So I'm gonna walk through the point system first, then we do the pseudocode and implement the code. So here is maybe I'm gonna open another one because last time this will be better. Um, how we gonna go work through? Okay, so this is the sorted array for the sample here, and so let me see how I'm so go. So first we need to initiate initiate um initiate the like how we gonna iterate the array like the given array, right? So basically the question is ask us to find the three three number which is triplets, and the when they added up it will equal to 0. So we're gonna first initiate where we're gonna iterate starting with let's say because normally we just iterate the index 0, the first element, right? So we're gonna iterate that one called the current not iterate, initiate called the current num. Um, so we set the current num because this question we need to iterate 2 times. The logic is why need 2 times. The logic is first we iterate. Hold on. AlgoBus. First, we're gonna loop through this array, right, from first element to last element, and we already sorted them. So how we gonna find which are the three numbers um, sums up equals 0? So we're gonna compare every number to -8 to find out the other two number, is it equal to -8 or not. So that if we found that, then we just drop in the 2D array like this. See, so the sample output -8 has two triplets. So we find the two pairs make it triplets with the -8. Then we're gonna do our second iteration, which is move second element and find the rest element where it add up become 0 and make it another triplet or not. The reason we need to set our current num is because in normal situation and easy problems, we just iterate from the first number, then go next. But this time, since we need to find the other triplets, so we're gonna iterate the first one and find the two numbers, make this one, then second one, find the two numbers, make a -6 become triplets. Then we're gonna third loop third time to find the other number equals 1. This is the logic. Then afterwards is like that. That's why we need to set the current num, because it's not always the first number. It's just happen this example is the first number. So this is the logic why we need to initiate a current num variable. Okay, do you guys understand what I mean?
Yeah, I think a little bit. Yeah, not completely, but I think
Because in normal situation, we don't need to initiate a variable called the current num, right? So what I explained why we need to initiate current num is because our starting, when we do for loop or while loop, our when we loop, we have a starting number, right? So the starting number will change, not always start index at 0. You understand what I mean? That's why we need to create a variable called the current num. So we can see current num, or we can say starting num, which is the starting point. So left. Then we need to initiate our left point and right pointer. So we need to initiate three stuff first. Then then the logic is a formula. So the logic is we will initiate another thing called the current sum. You can name that one too. So current sum, it will be because we wanna have the triplets which has three numbers. So it will be current num. I'll just say cn. Cn plus, so left pointer like this, but we need to get to the left point number, so will be left num, right? So right pointer, you will be right num. So the logic is current sum will compare with target sum and see if it's equal or not. So our target sum right now is 0. So we need to find the three numbers which equal to 0. Then if we find that three numbers, we throw in our triplets 2D array, which is look like this. just throw this in an array. So this is the logic. So we're gonna loop it. So can someone tell me which is our first current sum now? Oh, sorry, current number. So look, this is our sorted array, right? Where is our here? This is our sorted array, which is our current num for this iteration.
So this is the first loop?
Yes, this is, we're gonna loop this sorted array. Since we need to initiate left pointer and the right pointer, we need to sort it to, move left or right.
Wait, are you sharing your screen?
Huh? You cannot see my screen? Can you guys see my text editor screen?
I could not. I just saw a big
I
blur. I don't know why.
Okay, I'm gonna reshare then. Just share my entire.
I just saw like, I don't know, like a pixelated logo or something. It was weird.
Oh, no wonder you guys didn't have any response, because I couldn't see you. Once I see the screen, I couldn't see your guys' face. Okay, so are you guys see the text editor now?
Yeah.
Okay, so
yeah.
okay, so before you guys don't even see the text editor. So step one, we're gonna initiate 4 variables. Then step 2 is our iteration. So first iteration. Okay, can you guys tell me, for our first iteration, we're gonna loop through this sorted array, right? So which one is our current num?
So, sounds like our current number is going to be -8 to start with.
Yeah, current num will be, I'm gonna write here. Current num is -8. Which one is our left point?
Is it -6 or?
Yeah, yes. The reason is not -8 is because we want to start with the second one and the rest to compare with the current num and find the triplets. You understand? So current point, you will be start from current. How I'm supposed to write this to represent that?
So, it should be current num plus
I
1.
plus 1. No, this is pointer.
That's what I'm saying. The pointer is going to be the index of current num plus 1.
Index plus 1.
Yeah, that's probably the easiest for now.
Okay. So, what is our right pointer?
So is it 12?
Yes. No, pointer, so it will be last index, right? So it will be length minus 1 because it's the last index, right? So left point will be I plus 1 because the current num may be not the first one, right? Or we will see current num will be always index 0, then the left point gonna be 1. Or I plus 1. That part I am not so sure, but the logic is the left point is the one next to the current num.
You're saying you're not sure about which logic?
Left pointer. So the left point is supposed to I plus 1, right?
Yes.
Okay.
Because current number should just be the index. So it maybe shouldn't be -8. It should just be, I
Like
guess, technically 0.
Yeah.
Or
Yeah,
since that would be the index, the index would start at 0. So it should probably be 0.
Yeah, so current noun could be like a -6.
So current noun could just be I in this case,
Yeah.
and then left pointer could be I plus 1.
Right. So current noun will be array at index I because it's number. Then this is the pointer. Okay, so we are good at that. We are agree with that. Okay. Then we're gonna no. This is pointer, Davian, not a number. This is LP, left pointer.
Oh, it's just supposed to be the
I plus 1.
okay.
Yeah. Okay. So we're gonna do our first round. So this is first iteration, first round. We're gonna do it. First iteration, first round. So that will be -8. Because current noun is -8, right? Plus -8. Then here the left noun is -6, and the right noun is 12. The point system. So that will be equal to what? -2.
Yeah.
So -2 is it -2 equals 0. 0 is our target sum.
Yeah, they're not equal. Yeah.
Yeah.
It is not.
So not equal, then negative it's smaller than 0. So we need a bigger number, right? Bigger number.
Yep.
Big number. That's why if we need a bigger number, what do we move?
You want to
Do we
take
do
that
move?
away?
Okay.
Move
Take a,
to
so so let's see if it's less than a target number.
It's sorted from
So-
least to greatest.
And it's sorry. Okay. So I guess we want to increment the left pointer.
we don't need a do you like split screen or not split screen? Because okay, so what is our left pointer now? Left pointer now, left now. So here
Oh,
our left pointer, right? It is -6, and the
Yeah.
right pointer is this, which the right num is 12. So if we need a bigger number means we need to move left pointer to right to get a bigger number. Then the right pointer still stay there because it's already the biggest number. We cannot find a bigger than 12. So we will move our left pointer to right. Okay.
yeah.
So so what is our current noun now?
So right now our current number is still -8, or
Yes, still -8 because we didn't move anything, right? Because we
No.
want to find that the rest two numbers add a -8 become 0 because the target sum is 0. So we find the -6, 12, which is not to make that happen. So it's too small and we need a bigger to make that happen. So we move our left point from -6 to 1, so it becomes 1. And our right number
Yeah.
to 12 because it's already the biggest. So that one will be, that is equal to what?
5.
That is equal to 5. Oh, let me see. -7 plus 12. Yeah, 5. Yes, it's 5. Compared to target sum 0. So 5 is bigger than 0. So we need a smaller number. Need a
Yeah.
small. This is small now. Okay, so if we need a smaller number, then we just gonna move. So we only move right pointer to left.
Yeah. To the left.
Smaller, yeah. And the only move right pointer. So you will from 12 become 6. But our left pointer still 1, right? Are you agree with that? Because we just moved.
Yeah. I think I understand. Yeah. I agree on that. Yeah.
So second round. Okay. So we're gonna become third round. Third round move. Since we need a smaller number, we move right pointer to left, and the left pointer still the same, which is 1, and the current number is 8, and one still 1, and we just need a smaller number become 6, so that is 1, and sorry, 6.
6. Yeah.
6, so that is 7, -1, right? -1.
Yeah. Yeah.
-1 and 0, which is smaller than 0. So we need a bigger number. Bigger num. So when we need a bigger number, we move left pointer to right. Left pointer to right. So right now our left pointer is 1. So we move to right, it become 2. Right
Yep.
now it's 1, we become 2 now. So it will become 2. And our right pointer right now is 6, and we don't need to move that because we need a bigger number, right? This is the biggest number now. So that is 0. So is it 0 equal to 0? So it is.
Yes.
So we found the first pair, So first pair is -8, 2, and 6. I'm just gonna put this one here. Okay, so here is what happened. Right now our current num is here, and our left pointer is where?
2.
2. This is the left pointer, right? It's 2. Where is our right pointer?
The right pointer is at 6. 6.
6. Okay, so it's here. So now what should we do next? We find triple let. Then what should we do next?
We found
Then how
triplets.
we gonna move? Because it's already equal. How we left pointer, right pointer, it's equal. Then equal to target sum. We don't know. We need a smaller number or bigger number.
Move them both.
Okay, sounds good. How we gonna move both?
So you move. Now this is gonna sound confusing. You're gonna move the left one to the right, and then you're gonna move the right one to the left.
Yeah. Okay.
He's like,
Okay. So, but remember, we're still in our first iteration. So first iteration, not interaction, it's iteration. First iteration means our current num is -8. Okay, that is
Right.
our first. Okay, I'm gonna move this one to here. No. How I'm supposed to? I don't really know how to do that. Cause we're gonna see negative sorted array. Is that sorted? Okay, we don't need that one. So we can see here. See better. Sorted array right here. Is that better? Can you see that? Okay.
Yeah.
So the problem right now is we found the pair, right? We found the pair, the triplets. Okay. So now what's next? So find the equal, find the triplet. Then we're gonna do so that was
So
fourth
we
round.
already added the
Round.
triplet to the array, and then
Yeah, fifth round. You say we're gonna move. We're gonna move at same time, right? We're gonna move
yeah,
left pointer to the right, left
yes,
pointer to right, and right, and the same time right pointer to left.
yes.
I just put this. Okay, left. Okay, so now what? Now our tell me what is our current number?
So okay, so now that we found our first triplet, so
Yeah.
current number. So our current number would still be -8.
Yes. What is our right? Since we move left pointer to right, right pointer to left.
Yeah. So then our new left pointer would be at 3.
Yeah, because we are two, right? We move to the right, it becomes three. This one, so it becomes three. And what is our right pointer now?
So since we're moving to the left, so our right pointer would be 5.
Yes, 6 and 5. So that will be okay. So that will equal 0 again.
Yep. Yep.
So we found another pair.
Yeah. Yeah. Looks like we did. Yeah.
Okay, find the second triplet, right? That's pretty good. Then we just threw that one in. So first one is -8, 2, and 6. Then third one, now second triplet is -8, 3, 3, and 5. Okay, so what next should we do? What's next?
Let me see. So I think after that point, it would seem that the left pointer and the right pointer are equal. So I think we will need to update the current num to
Yes.
that's
So
the first thing, yeah.
why?
So yeah, from my understanding,
So right now left point is here, which
yeah,
is
Right
3.
now,
Right
yeah,
point is 5, right?
right,
So remember, the logic is one. Remember before was 6 and 2 and 6, right? Then since it's find the triplet, we just move both pointer. So right now we just move left to right become 5, then right to left become 3. Then it's overlaps.
right,
Overlaps. The reason overlaps, we need to reset our current num is because we remember our integers are not repeated. This is the in the prompt. It's requirement the numbers are not repeated. So basically, we already compare every number with
hmm,
-8.
okay, okay,
So we don't need to do more because if we do, it's just gonna repeat. Because if we
right,
do like
right,
3 move to right, 5 move to left, then you're gonna become -8 plus 5 plus 3. Then
oh
5
yeah,
will become repeated. But
yeah,
the question
okay,
told us question told us it's not repeated. So next that's why we need to reset our current num. How we gonna reset?
Okay. Yeah. Okay. If you want me to take that. Okay. Yeah, I'd say updated. Increment the current num by 1, so now it will be -6.
Yeah, so we just go to our second iteration. Our current noun becomes -6, right?
Mhm.
Okay. So our first iteration is done. So we're gonna start second iteration. Iteration. Okay. So first iteration is done already. I say and the first iteration. Iteration is done. So second iteration is our current noun. We still need current noun, left point and the right pointer. So current noun become -6. What is our left pointer?
Our left pointer, the way we define our left pointer would be 1 after the
Yeah.
so
So,
yeah, 1 after the current num, so it will be 1, 1.
yes, the left noun. So the left noun will become one, right? Because we made our function left pointer is I plus one. So what is our right pointer?
Okay, so for my logic, we say that the right pointer is the last number in the array, so it would be 12.
Yeah. So that will be. Are you agree, Davian? Our in second iteration right pointer still 12,
Right
which is
pointer is gonna stay 12. Yeah, right pointer is gonna stay the last number.
so the right now still 12, right?
Yes.
Okay. So I'm gonna look around. Each other. Okay, so now we become. So now we're gonna do our second iteration. Second iteration, first round. So right now our current number is -6, and the left number is 1, and the right number is 12.
Hmm.
So that is equal to what? Uh,
7.
7. Okay. Yes, 7 compared to 0. How is it? So yeah,
It's
7 is
too big.
bigger than 0, right? So we need a smaller number. Smaller number. Okay, so if we need to smaller now, we need to do what?
So if we need a smaller number, we should move the right pointer to the left. By
Yes, yeah, left to by 1, right?
Yep, yep,
By 1 index. Okay, so right now our current number still -6. Are you guys agree?
Mm-hmm.
yes,
Okay, so we need to move right number. So left pointer still stay the same, which is current number is so still here. Sorry, this is not really good. Still here. Then we move this one to 6. Okay, so our become 12, become 6. So that is -5 plus 6, which is 1. Negative, yeah.
yeah, 1.
So 1 is bigger than 0. So we need a smaller number. Okay, so if we need a smaller now, we're gonna move same right pointer to the left and the right point uh by 1 index. Right pointer to left by 1 index. Now current num still -6 and what is the left num? Still 1, right?
It's
And
still 1. Yeah,
so right now our in last round it's 6. We need a smaller one. We just move to the left. It become 5.
yes.
Yeah. Okay. It become 5. Okay. Then we have -5 negative, so it becomes 0, and it's 0. So we find so decision is we find the triplet again. Find the third triplet. So which is -6, 1, and 5. But since we know the answer output is 3 triplets, right? We already got the answer. But the iteration stuff the computer did not know. So actually our system still running. It will not stop. It will not stop here.
Mhm.
You guys understand what I mean?
Yeah. So even though we found 3 triplets, it
Yeah.
doesn't. Our system will stop. Like it'll still keep going, right?
Yeah, because the reason we know we stop because we know the answer is here, right? But the system is still running, you know. So we will walk through the logic and see where we're gonna stop. You know, I'm gonna put that one in. So first pair and second pair, 3 and 5, and here. That will be -6 and the 1 and the 5. Okay, that was too big. Okay, so what will be next? So we
So
find the third triplet. What will be next?
So wait, we found the. Where are we now?
Right now, our current num is -6, and our left pointer not left pointer is here, and the right pointer is here.
Ah, right.
And we found a pair. And what we supposed to do?
So we push the pair to our triplets, or the push the triplets to the array,
Mm-hmm.
and then we increment our we move both pointers.
Yeah, we move
yeah,
again, right? Remember, it's just like the previous one. It's just the current num changed, become -6, but the logic is the same. Once we find the triplet stuff, then we just move the points same time. Move left to right, right to left. I
Mhm.
guess so far we never have left to left, right to right, right? Always left to right, right to left. Okay, so now we're gonna move. So we move left pointer to right. Okay, and right pointer to left. Same time.
Mhm.
Okay, same time. Okay, so right now, what is our current num?
So our current num is still -6.
Yeah, -6. Then our left num will be 1, 2, right, so it's 2, right?
Yeah. 2.
Okay, so what is our right pointer? It was 5. Move to left, it's 3.
Yeah.
Okay, so now it's -1.
Yep.
-1 with 0. So -1 is smaller than 0. So we need a bigger number. Bigger number. I just say bigger. So now we're gonna move what?
So if you need a bigger number, so you move the left pointer to the right.
Yeah, to the right. Okay, so right now we become -6 plus because we need a bigger so right now the left pointer is here, right? 2.
Mhm.
And the right point is 3. And since we need a bigger number, so we move 2 to 3. But 3 is still 3. Are you agree?
Yeah, so they're both the same then, same number, right? The
Yeah,
left pointer, right pointer.
yeah. Okay, so we find the triplet, right? Find the triplet, but the question says no repeated number. That's why we don't
Right.
want
No.
this stuff to put in the empty array. Got it? Fine.
Yeah. So yeah, in other words, the left pointer and right pointer should not be equal, right? Not be
Yeah,
the same.
we find the triplet, but the question say no repeat, no repeated number.
Not repeat, right?
Yeah.
Right.
So that is the reason we stop, I guess. Or do you guys have other reason the system stopped? So I
Yeah.
it's stopped because
Yeah.
once we find the overlap number, which is repeated, right? That means we already iterate every number, because we don't do one by one. We do left to right, right to left. So we compare two numbers at time, two numbers at time, right? So we already find all the number pair with -6. That's why we finish the loop. That's why the second iteration stop.
Right.
Find the overlap. Overlap system stop. Okay. So I think this logic is clear. Okay, so the we go to the pseudocode?
We can.
Yeah, okay.
Yeah.
We're gonna go pseudocode. Okay, we're gonna go pseudocode. Hold on. Um, this one? No, not this one. What? I guess I just moved this one here. Here. Okay. Oh my God, I don't. Why it's okay here? Okay, maybe. Okay, you guys tell me pseudocode, then I write. So what will be the first step?
Um. So the first step would be to sort the array from least to greatest.
Yeah, step 1. Go to the array. Ascending order. Okay, what is the next?
Next, we need a place to store our triplets.
Okay, hold on. Let me put that one here. We need a place to store triplets, right?
Yes.
Okay, so we need a place to store our triplets. Okay,
Exactly.
yeah, so we just maybe initial a triplet called the empty array. Sounds good. And we
Yes.
just push the qualified number inside the empty array. Okay, so what will be third step?
So the way the way goodness
Is
the way
our still there? our
Yeah, I'm
what is the third step?
Yeah, I thought you were snoring. I'm not gonna lie.
no, no.
Uh,
Uh,
wait, answer. Yeah.
so okay, so my guess would be to define the 3 pointers, or
Yeah, yeah,
since
yeah.
we want to use it.
Initiate. Maybe Davian says what? Initiate three. What is the third step, Davian?
Uh, so we need a way to iterate over all the pointers, and so I believe you said that we needed an outer loop.
So Davian, are we gonna initiate variables first or iterate first?
Uh, both technically. So no, because our variables are gonna change inside the loop. So I would
Yeah,
initiate the loop first.
yeah, we're gonna iterate first, right?
Right.
Okay,
Oh,
so
because we're updating each time, right? The left pointer, right pointer, and current num. That's why we're is that why we're initializing them in the loop?
Because our variables are going to change depending on where we are in the loop. So they should be defined inside the loop.
Okay, okay, yeah, that makes sense. Okay.
okay, so we're gonna use for a while. Can we decide now, or we gonna decide when we implement the code?
I'm not gonna lie. I tried to do it all in a while loop, and I keep getting runtime errors, and I run out of memory. So we're just gonna. I tried to be cool. It
Uh,
didn't work. Um, so I guess we'll just um because we need to keep track of, first of all, we need to keep track of where we are,
to start,
where we need to keep track of where our current number is
right?
first. But through the explanation you gave, like the numbers we compare are based on whatever the current number is. So to keep track of the current number, we should have or it would be easier to use a for loop for that.
Yeah. So we may use for first, right? We use for loop. We can
Yes.
use later, use for loop. Okay. Okay. So you mean since we're gonna iterate first, we're gonna for loop. So we're gonna initiate the variables inside the for loop, not initiate variable outside the for loop, right?
Right, right. Inside the for loop. Yeah.
Is it right, Davian? We need initiate the variables inside the for loop.
Yes.
You need variables. Okay, what variables we gonna need?
Yeah. What variables?
So we need to initiate current num, right? So it's kind of like a intermediate variable. Then we need to initiate left pointer. Um, if I write this, you understand left pointer and the right pointer. Or we can say left num or right num, because when we iterate. Once we, once we got the left pointer and the right pointer, we will know the right num and the left num, you know. So can we initiate now so our current num will be what? Or when we do loop we do that. Maybe when we do loop we do that. Um okay, so what's next? After we initiate the variables inside the for loop, what will be next?
Dun, 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 dun.
Let me see. So Okay, yeah. So once we initialize the numbers, uh, then we want to do a comparison whether those numbers, I'm sorry, the sum of those three numbers are either greater than, less than, or equal to the target sum.
Okay, so you say what? Sorry, it's inside the for loop, right, or outside the for loop?
Oh, okay. Oh, right. Oh, I'm sorry. Okay, so in the initial for loop, we've already defined the three pointers,
Yeah.
and then
So the one
let me
you
yeah,
talking about is supposed to inside for loop or outside for loop?
inside the
Yeah,
for loop.
inside. Okay, so inside we're gonna compare what?
So we want to take those three pointers and determine yeah, take the sum of those three pointers and determine if either they're greater than, less than, or equal to the target sum, and then do some if statement based
So
off those.
so we're gonna check is the left pointer uh um smaller than right pointer, or what should we check?
Oh yeah, so we want to make sure. Yeah,
We
yeah. That's so
we want
while the left pointer, yeah, the index of the left pointer is, or yeah, the left pointer less than the right pointer.
so we need to check if left pointer is smaller than right pointer. We don't need to check that because do we need to check that because we already sort the array.
Wait.
Um,
We need to check what?
Check left, yeah, suppose left number and the right number.
Do we need to check if they're what equal?
No, like here I understand the outward means we're gonna check we're gonna move our left pointer or move our right pointer. So how we gonna do that? The logic in pseudocode. So how we gonna first run?
So we've already started the second loop.
Okay, so check. I guess I think yes. That can you guys help me? So I think check if the left noun uh uh left noun is equal to uh let me see. So I don't really know this, but left noun are smaller than right now. No. I know is we gonna find
yeah,
the
yeah. I think the idea is that we want to make sure, like if I'm not mistaken, that that the left pointer and the right pointer are are either not equal to each other or they're not overlapping, right?
yeah.
Is that so? So I think yeah, I think we do want to check and to make sure that that's not the case where the left pointer is equal to the or it's yeah, it's not greater than or equal to the right pointer. If
So
I
we need to check if it's overlapping.
yeah,
Yes, to
exactly.
the left pointer and the right pointer is overlapping or not.
Yeah, make sure they don't overlap. Yeah.
No. If overlap, what we gonna do? We just out exit the loop, right?
Yeah, we exit the loop and we update the
We just
update.
return the triplet, which is empty array. You know, if it start as overlapping, you know. Okay, so how can we check left pointer and right pointer overlapping or not?
So if the left pointer is greater than the right pointer, or
if the left pointer less than right pointer, then we're gonna do what?
All right. So yeah, in that case, so I guess we can say yeah, while that's true, while left pointer is less than the right pointer, we want to use those three numbers that we initialized and determine whether they're
Yeah. I understand what you mean. So you say because we wanna check if the left pointer and the right pointer is it overlapping or not. So how we
right.
use pseudocode to represent this sentence is we check if it's left pointer less than right pointer. If it's yes, which means not overlapping, right? Right? Which means not
Correct. Yeah. Yeah.
overlapping. Okay.
Exactly. Yeah. Yeah. At that point, yeah,
Yeah,
if that's less than right pointer,
right.
they're not overlapping.
But
Yeah.
if this is not true, that means overlapping, right? So
Correct.
yeah,
Yeah.
okay,
Yeah.
now got it. So first we're gonna make sure it's not overlapping. Then we're gonna find the triplets to compare target sum. See if are they equal or not, right? Then we're gonna
Yeah.
find the
Yeah.
if current sum equal to uh, target sum or not. So the formula is so current sum will be equal to uh, current noun plus left noun plus right noun, right? And see uh, and compare with target compare with okay, so compare with target noun. So if current sum are smaller than target sum, what should we do? For target noun or target sum? Target sum.
Yeah.
So
So yeah, if the current number is so yeah, let me just try to refresh. Remember, yeah. So if the current sum is less than the target sum, then it means that we need a bigger value.
yeah, bigger
So
value. So we will move to our left pointer to
yeah,
right.
update to
So,
left point. Right.
so
Yeah.
that means left pointer plus one, right?
Yep.
Move to right. Okay. Um. Okay. So else if right
Hmm.
else if uh current sum are greater than target sum. What should we do? I
So
can
that
do
yeah, that would be the opposite effect.
that.
So
So we
yeah,
will
so
move to right pointer to left, right?
yep.
What that
Yep.
means right pointer minus one. Because move to left is minus. Because index number, right?
Yep.
Yeah. Okay. I can put this one. Move left pointer to right. Okay. Okay, geez, my notes is getting crazy. Put that one. Okay, so doesn't matter. Okay, so what else? Else if another else if is current sum are equal to target sum. What do we do?
So then we would update both the left pointer and the right pointer.
Updating.
So right, or
So
let me.
that means we found the triplet. So how we gonna through the stuff inside the empty array?
Oh right, yeah. So yeah, so then we just store, um, yeah, we store the triplets that we found where that's equal to the target sum into our triplet array, right?
Yeah. So how we gonna do? So I just write like a current sum. So we update. So we just gonna update our empty array. Because remember we initiate our triplet array as empty array. So we're gonna update triplet array. They come like this noun, current noun, and left noun, then right noun, right? I
Correct.
agree
Yeah.
with that.
Yeah.
Yeah. Inside, cause we have. Okay, so the outside this is 2D array. Outside the array is triplet empty array. Then we're gonna throw these three stuff inside the triplet empty array. Okay, so what's next?
So yeah, if I recall, yeah. So well, once we update the array, then okay, yeah. Then we want to then assuming that the left point and the right pointers are, I'm sorry, assuming that the left pointer is still less than the right pointer, then we want to update both the left pointer and the right pointer.
Oh,
It's, uh,
so I think now we're gonna reset. We're gonna do our second iteration, right? Then how can we use code to do second iteration? Because remember in logic it's like this. Then we're gonna move our current noun to next to like our current noun index gonna plus 1.
oh right, yeah, yeah. We want to update our current number, right? Yeah, right. So
I don't really know. I just say update current.
okay, yeah. What do you think, Devin? Any thoughts?
Yeah. Amy,
So
are you still there?
I'm still here. I'm trying my own problems and they all suck. So so we're at the current sum is equal to target sum. We've updated. We've pushed the new thing to the array. We've moved both pointers. I'm assuming. Wait, update current now. Okay, so this is after the pointers cross and the left pointers less than or the left pointers greater than or equal to the right pointer. So we update our current num.
Yeah, because I think we don't need to do the overlapping stuff because
No, it's extra time.
make sure it's not overlapping. So we already end the iteration. Like we ended the first iteration. Do you guys agree with me?
Yeah,
Since
because
we originally already says it's not overlapping.
and they have to be pushed in order. Like the sort order for the arrays has to be from least to greatest too. And if they overlap and we have duplicates, it'll mess up that order.
Yeah.
From smallest to greatest. So from there, the while loop should break out, and then the for loop would go to the next item and repeat the process.
Yeah, you're so smart. So here, current now, left now, right now. So we end the while loop, right? Exit while loop.
Yes.
Yeah, me while loop. And we're gonna do our for loop, right?
Oh yeah,
For
yeah.
loop
So again, we exit the while loop when they overlap, right? Is that what we're saying?
Yeah. So for loop continue. How we gonna continue? So for loop is for in da 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 da. So basically, there is a while loop. Do all the complicated point system inside the for loop. Then we gonna reiterate the second current noun. So that means I plus one. So we just reset current noun become I plus one.
Yeah, I plus, or hold on.
But I thought originally we already say current noun is I plus one.
Um, or was that the? I think that was for the left pointer, right?
Oh yeah.
The for
Yes,
loop is
that's
for the current
so
pointer.
reset the
Yeah.
current noun index number become I plus one.
Yes, because we
Yeah.
declare in the for loop. So once we start a new iteration in the loop, the variables get redeclared.
Yeah. So we reset current noun index is I plus one. Then we our current noun become it's still the same array, right? It's still the same array. So become array I plus one. Are you guys agree? And we're just gonna do the while loop again.
Right.
The for
Yeah.
loop starts the while loop again because it's inside.
Yeah. Right.
Oh, I never tried those stuff before.
Yeah, so yeah, basically our
But the while
while
loop,
loop technically gets shorter and shorter.
at the while loop same logic. How can we make the while loop in one?
How can we make the while loop what?
In because right now, remember we have for loop. Then inside the for loop we have a while loop. Then we
Right.
exit the while loop once we find the triplet, right?
Right.
Then we just reset our current now index number for continuing the for loop. Then once we do the for loop inside the for loop, it become the while loop again.
Yes.
So we're gonna write a while loop again inside the for
So
for loop.
so when the for loop moves, so we started at index 0. When the for loop moves to index 1, it we recreate the pointers, and then the while loop gets started again, but all the numbers it's comparing are different because we're no longer comparing anything with index 0,
Mm-hmm.
because we no longer compare that, and the left pointer moves up one. So basically we each each time we start each time we each time the for loop creates another while loop, we're comparing a shorter and shorter set of numbers
Yeah.
until we get to like the third to the last index basically, and then we're just comparing the three numbers, and then from there it breaks out after that. So yeah, we recreate a while loop each time we start an iteration of the for loop, and each time we recreate the while loop, it's a smaller subset of the array.
Okay. So like the left and right pointers, as we were saying, like they
Because the
depend on
left
the
pointer
character.
gets smaller each time. So right now it's one, two, I'm up. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So the first time we start the for loop, we compare all 8, and then we compare all 8 in the while loop, and then the next time we start the for loop, we compare 7 numbers in the while loop, and then 6, and then 5, and then 4, and then 3, and then once we get when there's only 2 numbers, the for loop ends, because that's why it's array dot length minus 2 instead of the typical array dot length minus 1.
Yeah. Can we implement a code? Because I couldn't do the pseudocode anymore after exit the for loop.
There's no more pseudo code. You just return triplet.
Just repeat. Yeah.
And so
I think
we return triplet whatever it is. So
yeah,
it either
there,
returns the numbers or an empty array.
yes.
Mhm.
Okay, so it's done, right? The pseudo code.
So yeah. We don't need to say return empty array because either triplet's gonna have an array inside it or it's just gonna stay empty.
Yeah. Okay, so we can do the code, right? Implement the code now.
This
Yeah.
looks good. We should be able
Okay.
to.
Yeah.
Yeah, I'm mad. I tried to do it all in one loop and it just kept crashing. I was like, this sucks. And then I just tried to rewrite what they said and it still broke. And I'm like, why? But so I messed up somewhere. But
So are you gonna do the code or
it's up to you. You pick.
I guess probably you are more advanced. Oh, we can do it together an hour. We can just think it together. If we stuck, maybe we can do next time. Continue. What do you guys think?
Okay. Yeah. So who's going to be the driver?
I forget which one's the driver.
Okay, so are you
Okay.
gonna do it, David?
So what, I tell them what to write?
Sure. You can tell me what you
I don't
write.
know who driver navigate. So which one's the which one's the navigator?
I think the driver is the one who tells you what to write. If I'm not mistaken, the navigator is the one who
Yes, tell what you write.
follows whatever the driver tells them to write. So, like I think last time I was a driver, and then I think I had Devin was a navigator last time, or
Probably.
The driver last time.
oh okay. Oh.
Oh yeah, that's right. Okay, so I guess I'll navigate. Someone got yeah.
Howard, can you write? I don't know how to write this code.
Okay. Yeah, I
You,
guess I'm
expl-
trying to.
you explained it so well. You explained it so well.
Yeah, I think you should take this.
I couldn't do the while loop stuff.
I mean,
Okay,
I've just been
just ask-
staring at the solution for the past 30 minutes. Why lie? So I so I got that part. I was just but you
Okay,
explained it so well.
that's fine. I can do. You just tell me what to write, because I am beginner.
I'm a
Ah, yes.
beginner too because I no longer have the solution up, so I gotta explain it like I know it.
Okay. So I gonna sort the array, right? So I just gonna do like last time. How did you do that?
So
A B.
oh yes, we have to sort the array. So we're just gonna run array.sort.
No, that will not work. Remember, we need to do the callback function.
No, we're gonna put the callback function in the sort.
Okay, so array.sort.
Yes.
Yep.
And then
Okay.
inside we put the callback function.
Okay, so we can put what A.
It's gonna be A and B,
Uh-huh.
and then A minus B.
Okay. Do we need a greater than 0 or something like that?
No, because it's gonna return whatever A and B are like index 0 and index 1, so it's gonna return the value of A minus B. If A minus B is negative, then it'll sort the smaller number first.
Okay.
That's how the sort function works. So we don't need
Okay.
anything else.
This is ascending order, right?
Yes, ascending order.
Okay, ascending order. Okay, so we did this one, so we're gonna create a triplet, right? So we're just gonna do let or const.
Const.
Okay, const triplet like this.
Yes. Because we're just
Okay.
gonna push items into it. It's gonna be an array no matter what.
Okay, then we're gonna do for loop, right? Step 3 for loop.
Yes, we're gonna create a for loop.
For
I's equal to 0.
Do I need to write let or just write var?
I would prefer let, but
Okay.
technically it doesn't matter.
So just let I equal 0, right?
Yes.
Oh, no, 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 no. Oh, yeah, yeah, yeah. Because we're gonna do this one. This is not a current number, remember?
Right. The pointer is going to be whatever's next to left
Yeah,
pointer is going to be next to the current number. The
have audience. So this
Yeah.
is I is index 0 here. Okay, so
Yep.
I equals 0, then I smaller um array dot links.
Yeah.
yeah. Oh wait,
Uh,
minus. So in this case, we're doing -2.
so wait, iterating why need to be -2?
Okay, so we have 1, 2, 3, 4, 5, 6, 7. We have 8 numbers in our array. All
Yeah.
right. So
Mm-hmm.
with 8 numbers in our array, the numbers are indexed from 0 to 7. So because
Mm-hmm.
they're indexed from 0 to 7, we normally have the loop end at length -1 because that would
Yes,
equal to 7.
yes.
But we need to compare 3 numbers, and because we need to compare 3 numbers,
Yes.
I is going to be the last value of I we want to compare is going to
Mm-hmm.
be array.length -3, and then the left pointer is going to be array.length -2, and then the right pointer is going to be array.length -1. In our last loop, that's how we want it to be.
Oh, oh, can you explain a little bit, please?
Okay, I'll try to.
Can you
Um,
come to the, you see on the right has notes? It has sorted array on line 22. No, in the notes.
oh, and
Can you,
then
yeah,
so
can you
switch the.
explain one line 22? Can you explain what you just said? Why need the array that links -2?
So in the this that is me. Okay,
Yeah,
so
I
this
can
is so
too.
yeah, basically the first loop. Oh god. Uh,
Oh yeah, don't put a number.
I didn't know I was gonna do that, but anyway, I probably should have been 0. So,
That's
God,
fine. I understand.
I was like, stop! Why is it moving? I'm getting confused. I hate it all. I don't know. God, dang it! All right. So, and 3. Why is it doing that?
Okay, can you please
Alright.
delete and redo it? You just want to
Yeah.
copy sorted array, right?
Yeah, I'm just getting rid of this. So, uh,
Okay.
and then is it 2?
Oh, you are so smart. He explained everything.
Okay. So, this is uh basically I equals 0.
Yeah.
Yeah. Or yeah. 1, 2, 3, 4, 5. So, and the length is 7, right? So our array.length is equal to 8, for
Yeah.
example.
Mm-hmm.
Array.length is equal to 8.
Mm-hmm. Yep.
Yes.
So here's where we are. We are 0, 1, 2, 3, 4, 5.
Yeah.
So
Eight
once I is equal to 6, it's
I equal to 6.
just 6
So 1,
and
2.
12. Uh, so I is equal to 6. The 0, 1, 2, 3, 4, 5, 6. And then I probably should have did length, but here the array now I'm explaining it wrong. That length is equal to 8. So once we get here, current or that was due division. Current number
Mm-hmm.
is equal to 6. Left number would technically be equal to 12, and because right number is the length minus 1, it would also be equal to 12. So we're at index 6,
Okay.
length is equal to 7. Or we're at, yeah. So that means 6 is confusing. Basically, we would just put index 7, or yeah, or sorry, 7th number in array,
Mm-hmm.
and then the
Yeah.
8th number in array.
Okay. Can I ask a question? So you mean this is radar length equals 8 for line 24, right? So you mean if the scenario, if our current number is 6, then left number 12, then radar length minus 1, right number should still be 12, right? This is
Sorry,
what.
yeah. So that's how I was trying to explain property. For so when I is less, while I is, don't do that, array dot length minus 2, because this index, when I hit 6, which is here,
Mm-hmm. 6, yeah.
the length is 8. So once we hit this point, we no longer want to be comparing numbers because there's not 3 numbers to compare.
Okay, got it.
So
Only two are left.
yes, because the left number and the current number, or the left number and the right number would be the same because there's only
Yes,
2 numbers. So we want to
right.
stop the loop before it gets down to only 2 numbers.
Okay, so we want before 6. So our last element will be 5?
So we stop at index 5, which is the length minus 2, is we're going to stop at the 6th element.
No, radar
I mean,
minus 2. Yeah,
the number we're stopping at is 5. I know that
yeah,
it's all sorted, so it's weird, but yes, the number in the array we stop at is 5. Its
yeah.
index just happens to also be
Right, right,
5.
right. Understand. So that means our current number will stop at 5 in our this loop,
That'll
right?
be the last loop. Is starts at 5. That's the last loop we're going to do.
Okay, got it. So we have since when we work through the code is we work through first iteration -8, second iteration -6. So our last iteration will be 5, right?
Yes, because
Oh,
once we hit 6, 6 is going. The position of 6 is going to be less than array.length minus 2.
yeah, it's only we don't have 3 numbers anymore. That
Yes.
makes I got it. Our did you got it?
I think so. So,
Ask.
yeah, let me think.
Don't
So,
understand, you can ask her. Yeah.
so okay, so Yeah, let me. Okay, sorry. Can you explain one more time why we do array? Stop at array dot length -2 again. Sorry. Just
Okay. So okay. So again, what we're comparing here's what we're comparing, right? We're comparing I is less than array dot length -2. That's
Mhm.
what we're supposed to stop the loop at. The reason why is we go through index 0, index 1, index 2, index 3, index 4, index 5.
Mhm.
Index 6 is not less than array dot length -2 because the array length is 8. And the reason we stop at when I equals 6 is because we see here where I is equal to 6, there are only two numbers in the array. We can't compare triplets when there are only two numbers left to compare.
Oh, okay. Okay.
So we have to stop an extra number short, to which is here, so that we have three numbers to compare.
Oh, I see. Okay. So, oh, I see. Okay. So, because if, for example, we were at 6, then we only have two numbers, 6 and 12, right?
Yes,
Yeah.
But
because
that doesn't answer the question since we're supposed to have triplets. So that's why we stop at, or we can go up to array dot length -2, right?
yes,
Yeah. Which is this number 5 element.
5.
Yeah.
Oh, okay, okay. Yeah,
Yeah.
yes,
that makes more sense.
because we see what I is equal to at each point. At each point, I is equal to the first number in the array. So once we get to I is equal to 6, the first number in the array is 6, the last number is 12. There's only two numbers. It's impossible to have a triplet. There's no point.
Oh, okay. I got it now. Okay, that makes more sense. Yeah, because if we have 6, then the left and right pointer would be the same then. Like,
Left
Yes,
still right still this.
because
oh, okay, yeah. Since if we're at 6, then yeah, it would mean that left right pointer are pointing at the number 12, for example, which
yes,
is not what's supposed to be, right? I mean, like, we're not supposed to have repeating numbers in a triplet. So,
right. We're not supposed to compare the same number. It's supposed to be unique numbers. We're not supposed to add the same any number to itself at any point.
okay, all right, yeah, okay, yeah, that makes more sense. Okay, yep, thank you.
Sure.
Okay, thanks, Davian. Great
Yeah,
explanation.
good explanation, Devin. Yeah.
Yeah, Davian. Okay, what will be I still plus plus because we increment by 1, right?
We still increment by one.
Yeah.
I plus plus. Okay, so we're gonna go inside the for loop. Check if the left point and the right point is overlapping or not. I'm gonna put this one inside the. Okay, so we're gonna put a while loop inside like this, right, David?
Oh, well, we can't compare anything until we
We
can't
have to
compare.
initialize it.
We can't
Right.
compare until we declare.
Oh,
Boom.
yeah, I
Let's put that
forgot.
on a T-shirt. So yeah, we have to
That's a
declare our
good
variables
slogan.
first.
Okay, so
You should make a shirt, Devin. Yeah, make that one.
yeah,
You should wear it next time.
in
Yeah, I'm gonna
this
wear it on the call. I'm gonna go to Teespring. It's gonna be
Yeah, show
available
show everyone in the class.
when it's by the time this airs on YouTube.
You
Teespring.com.
can sell it too. Make some money.
So we gotta declare our. Wait, who's writing? You're writing, Jennifer? Yeah. So we have to declare
okay, the
um, our left and right variables.
let or constant.
Uh oh, let or const. I'm sorry. Yeah, I was like, what? Um, l- l- let. Sorry, I had to think about it because
So
they're
what do we need to declare? Current
so
number?
so we need to declare left and right. Our current number is going to be I, whatever I is. So we don't need to
I
redeclare that. Yeah, will we declare I?
index current number. For example, here.
Well, okay, we could do current number. I was just gonna do array I the whole time, but we could declare current number too.
Okay, that's fine. I do that one. Array I.
I mean, if it's whatever's easier, if it's easier to read current number, then we could just do current number. I'm not against that.
Okay, current. I can do that. Current number is array I, right?
Yes,
Mhm.
make it easier to read.
Yeah.
And then left is equal to
Sorry.
Left pointer or left number?
it's going to be the point no, it's going to be the index. So it's going to be the pointer. So it's going to
you want to
be
make sure that
I plus 1.
Left pointer
Yeah.
is equal to I plus 1.
Right. Yeah.
Can I write LP? Too much words like this.
Whatever helps you.
Yeah, it doesn't look like a good name. Then right pointer, yes. I can write this first, and when we do left, just put the index. And right pointer is array dot links minus 1.
Yes.
Right?
The last number in the array. So array dot links minus 1.
Okay. Okay. So we initiate. Do we need to initiate the right number, or we can just do that? Just put array here. Okay. So what should we do next?
First of all, JavaScript is weird, so all these non-spaces are going to definitely be wrong.
Oh, what? Sorry.
My RAM is going crazy right now. We're gonna definitely need some spaces between these operators and these numbers and stuff, because JavaScript's not gonna know what we're talking about. So like a space between the I and the plus, and like.
Oh. Okay.
Yeah. You can modify my code. Feel free.
I have to do that. Okay. Yeah. Okay. Yeah, just that. Fine. Okay. So now we're going to create our while loop.
Okay. But the logic is right here, right? So I just
wherever the logic is you can pick where to put it.
Oh, sorry, I left the meeting by mistake.
I was like, yo, who's joining?
I'm like, what happened there?
So we do while loop, right? Just
Yes.
here. While loop. While left pointer is
Left than
than right
the right pointer.
Yeah. No, smaller than the right pointer, right? Because you want to make sure no overlapping.
These are good name. Can we do better name represent pointer? Yes,
just maybe type it out. Left pointer, right pointer.
Left and right. Like, I don't know.
Okay, maybe left and right better, huh?
Yeah.
Yeah, that will be better.
In the interviews, you're gonna want everything to be readable, so don't go too short when you don't need to.
Left like this.
Yeah.
Oh, this is not index. It is index is the pointer, right?
Yeah.
I just that's fine.
I don't have the answer to that particular question accurately. For this case, we'll say yes, but like, I wouldn't try it in an interview. They'd be like, "No, it's not. I'm confused." So for now, we'll allow it.
Is this better or left to right better?
The more descriptive is always better.
Okay.
This is not. That's the difference between a coding interview and like competitive programming. If we were doing like competitive programming, we would just have A, B, C. Everything would just be a short variable name. But
Because array that is gonna be too long.
It is not.
Like this better.
You just don't want to type.
Yeah, just leave it for now.
You
Just
literally
leave it.
just don't want to type. Like that.
Yeah,
That's it.
just leave it.
There's-
Jennifer,
just-
don't worry, just leave it as it is.
There's
Yeah.
no other reasoning because you're gonna come back. Because you have to think like an interviewer. You're gonna write this code. You're gonna put this code into the code base. Someone's gonna edit your code 6 months from now. Probably you. You're gonna be like, "What is the left p?" Like, what is the
Okay.
left p? You don't want that.
Got it. Left pointer smaller than right pointer means not overlapping.
Right.
Then,
Yes.
then what's the logic next? Then we find the current sum is target sum or not. Okay, put this inside. It's in the while loop.
Why is your highlight color so hard to read? Or maybe it's only on my screen because I'm like watching on the live stream on this monitor, and then I'm like the actual editor is on my other monitor, and when you highlight it, I can't see a thing. But it's only
Okay.
on my screen. So yeah, we compare. First, we want to compare if they are equal.
Yeah. Huh? We compare equal. I thought we're gonna do the smaller or not. But
I
we
don't think
equal.
it doesn't matter. Or
No, because it's all else if anyway. In this case, it just depends on what you prefer. It's preference really. Some people want to check for the best case first. Some people want to check the worst case first, and then the best case if everything else fails. So in this case, yeah, we can compare the best case last.
Okay, then I need to change the pseudocode then.
I mean, we could. I don't know how you wrote it. How did you
Because
write it?
pseudocode say if left point smaller than right pointer.
So you wrote left pointer just write it how you wrote it. I can't read. I'm not reading comments like that. Write it how you wrote it.
Just
What are we
left
comparing first?
smaller than right pointer, that means no overlapping.
Right. No, I was talking about the if statements in between, inside.
Okay. Okay, so gonna put if?
Yes.
If what?
Yeah, yeah. I was looking. We're talking about the wrong, different pseudocodes. So yes, I'm talking about if the current, if the. Oh wait, no, we need to declare a current sum, and then we check if current sum is equal to target sum.
Pseudocode is say we need to declare the current sum and the current num. Current num we already declared. We just declare current sum.
Oh yeah, we need current sum. That's what we should have.
Is equal to current num.
Yep.
Plus I'm gonna declare left num too, cause I don't want to type that much. Left num is equal to.
why are we doing a left num?
Just the short array of index left.
Yeah.
No.
Okay.
Our array index left pointer, technically. Yeah. Oh wait. No, it's fine. It's the same. It's the same. It's the same. I had to double check. I'm like, that just looks wrong.
That weird. Okay, we can use that now. Okay, current num equals left num.
Yeah, this technically probably should have been left pointer and right pointer for the index, but it's fine. It still technically works.
Okay. So we get that one and see if it's equals to target num or not. So if we have target num, right, for the input target sum.
Yes.
So if current sum it's here. I'm gonna put pseudocode here. If current sum da 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 da. Okay, I do this one. You guys check if I am right or not.
You gotta check your own code. No, I'm kidding. So yes, we're gonna check if current sum is equal to target sum.
Yeah, if the current is smaller than target sum. Are we on the same page, David? We need to be on the same pseudocode.
Oh, you're writing that one first. Okay, that's fine.
Yeah. So if current sum smaller than target sum means we need a bigger number. So we move our
Left
bigger
pointer.
pointer to plus plus. Left pointer plus plus. Oh. Then what else? Else
Also,
if
Yeah. Else
yeah.
if current sum is bigger than.
Else if.
current sum. I'm gonna put this one here. That's fine. It's working.
Yeah, you can put that. Yeah, yeah. If you have the pseudocode, yeah.
No. I know he wanna do this space stuff.
Does that work? Like, does that run?
So we're gonna check else if right here. Okay, else if current sum smaller. What? 1 minute. Move left to the right. Move. Okay, so we got this one already. We need to get this. This is how you iterate the code. Okay, so else if current sum is greater than target sum, and move right pointer to left, so it will be right pointer minus minus.
Yep.
Okay.
That is how that works.
Yeah. Okay, then we're gonna do if it's else if again.
We can.
Oh, we don't need the else if. We just the other one.
Oh yeah, else or
That
Well,
that means
do
no,
we
we
do
still
the else
should do the
statement,
equal.
or?
You can get weird stuff. It's still. Or we're gonna do a separate if. I'll argue about why
Yes.
coding choices at the end. You can just write else for now. I'll
So
argue
we just
that at the end.
return, right? Oh, we just update because we already put a greater and less than. So we already know the third scenario is equal. So we just update the triple letter array. So how we gonna update triple letter?
Wait, I gotta scroll.
Reset, because right now our triple letter array is empty array.
Oh, whoa! Don't do the equal. No. Okay, so sorry, I was like a thousand thoughts in my head. So yes, triplet is a const, so we cannot redeclare it. It's always going to be an array, but we're creating, what do they call it? A two-dimensional array. So it's an array of arrays. So we push a new array inside of the existing array.
So triple letter push.
Yes, and then we would push an array with the values.
Okay, push current num and left num. Okay, so where is my left
Num.
and right num?
And update the pointers.
What did you say? This good?
And then update the pointers.
Oh, okay. So we don't exit the loop. Then update pointer.
Yes, we update both of them.
Yeah.
Oh, both pointers. Yeah. Both pointers. Right pointer. Okay, so I just put this left pointer gonna be plus plus and right pointer minus minus.
Correct.
Yeah, yep. That looks right. Yeah.
Then once we update, um, I know our walkthrough scenario, you find the second triplet. But then
So yeah,
find the triplet, then we find the overlapping.
yeah. So each time we update these pointers, the while loop is gonna keep comparing
Yeah,
until this is no
um,
longer true,
yeah.
and
So we're
then
gonna,
we break out of that, and then we start the next for loop.
okay, sounds pretty good. Excited for loop. Okay, here.
That's the end of the. That's the end of the while loop.
While loop. Okay, so I can see step 2. Okay, so continue for loop.
So we're still inside the for loop. Yeah. So that the while loop is going to be the last thing that our for loop runs before it starts over again.
I'm gonna close the while loop so you will not be confused. Just forget about while loop for now.
Yes. Wait, it is closed, is it not?
Yeah, I click this, then close the while loop.
Okay.
Then for loop, okay, we did this, then for loop it will be I plus 1, current number becomes array I plus 1. We're gonna reset current number.
Correct.
So I just say current number. Cause
Oh
if
no 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 no. So because we declared all of these variables inside the for loop,
uh-huh.
all
Yeah, I
these
think it resets
steps
it
are
for you.
going to
Yeah.
run again. All of them.
Yeah, because it's gonna
So
reset for you.
when I becomes 1, it redeclares these variables with the new value of I. So
So
current
current
num becomes array
as
index 1, left pointer becomes 2,
mhm.
and yada yada yada.
Oh,
It recreates the while loop with the new pointers, etc.
yeah, that makes sense. Okay, so we don't need to do that. Then we just find the third triplet. Uh,
So yes,
because
these loops should find
let's
all of them.
do the thing again. So we just gonna return triplet.
Correct.
Okay, return
Wait, is that
triplet.
the for loop or the? It should be outside.
Oh yeah, outside the for loop, right?
Yes.
Because here I got your point. Since for loop with here current number, since we do for loop, I current number already becomes array I plus 1. Then you're gonna do while loop again. Then find the triplets. Then do again until num equals current num equals 5. Then you will stop because array dot links minus 2. So I think we can just return triplet
Yep.
Yes.
outside the for loop, right? Outside the for loop.
Outside the for loop. So after everything is done.
Yeah. Okay.
Yeah, that's the yeah.
That makes sense. Outside for loop, return triplet. Then we gonna okay. So this stuff I just gonna put here. That makes sense. Put here. We don't need to put anything here. It's just the logic. Return triplet. Then we don't need to return empty array, right? Because if we didn't find anything, the triplet will be empty already.
Yes. So if we don't find anything, triplet remains empty, and we just return triplet anyway.
Okay, sounds pretty good. Should we run it? Test it?
Yeah.
Yeah.
Yeah, I'm going to the bathroom. Yeah, I'll be right back.
Okay, I'm gonna test it.
He's gonna miss the big reveal. No.
Okay, right
Yeah. So my
here.
friend says he's gonna join the next one. He had to deal with work. He had to debug some other projects.
Okay. Oh, it's failing.
Oh dear. Well, can you run it and see what the errors are? Run code?
Run this. Some tests are fail. That one is fail. Oh, so many fails. Okay, so what's the problem? Our code output. Okay, we have duplicated. That's the problem. The problem we have duplicated the pairs.
Mm-hmm.
Duplicate the two
Wait a
times.
minute. Wait,
Can you
wait.
see my?
I can see. Yes. So,
Yeah.
well, don't zoom in. Don't worry. I need to see the code, and you've highlighted all the code, so I can't really see
Where
it.
where is right this? No. You will highlight? It didn't highlight. I think the problem probably is step 30 line 38.
Okay. I need
Maybe we
to.
don't push it.
I need to copy it in mine because I can't see. Okay.
Maybe
So,
we
the. Wait a minute. So if, else if, is there a format thing? No. Uh,
Mm, hmm. Would it make a difference if it did else statements? I don't think so. Right?
uh,
uh
no.
it has duplicates like a duplicated triplets.
Hmm. Okay.
Yeah, that's.
Ooh.
Uh,
See the output supposed to be this, and our code output has duplicates. I'm gonna probably Google why have to duplicate to the array.
I think I know why. Well, I'm not sure. Let me. Hold on. Okay, so that didn't fix it. think I want to say I know why, but I'm not. Oh.
Can we debugging like the middle point? Oh, maybe I return triplets inside the triplet and return empty array. I tried this.
Now begins the debugging process. It's so much fun. Oh my goodness.
Oh, does it mean I need to write a sorted array? Then we need to loop through the sorted array, not the array.
We sort the array. We sort the same array.
So when we say array.sort, it's already saved in the sorted variable.
So when we run array.sort, we're sorting the array that we get passed in.
The
So instead of
input.
creating a new one, we sort the one that we're given.
Okay.
I'm trying to think. It could be an ordering issue. I'm not sure.
Maybe we need to put a var sorted array. Sort. I try. This.
Oh my goodness, this is play some
This
Jeopardy music.
we haven't go to the difficult one yet. Okay, I'm gonna try this. see if it's working. It's same thing. So when I do sort array or not sort array, it's pretty much same thing.
Yeah, I figured that would be gonna be the same thing.
Maybe you research on internet a little bit.
You're gonna search the internet now.
I'm in camera. If I stop sharing, I can search on internet. Can I stop sharing my screen
Sure, why not?
and search, that even worse. Okay. I'm gonna stop shit. Oh, I was left. He
No.
already, I don't even know he left.
Why? What happened?
Jeez, we haven't solved the problem. He already left.
Well, can't hang. Oh man.
Okay, we need to get the answer. Three, num sum.
And I, I still don't see
Is this one
what's
same
going
as
on.
the Algo expert?
Say what?
Lee code, same as Lee code, right? Three num sum.
Should be. I'm looking, and I still don't see where the code. I've made changes. I've changed the order. I got rid of variables. I still don't see like the issue.
Okay, we are recording. We need to get the answer.
I
Algo
I'm
X.
aware this is so. This is not. This is not great, but we'll figure it out.
Okay, I gonna mute myself a little bit because I'm gonna see internet solution.
Oh my goodness. I'm gonna. I gotta get rid of these comments. I gotta clean up this. I need to see all the
So
code.
this is Facebook interview question. That's why it's different.
No, but I understand it. I'm just. Why is it not working? Oh yeah. Because I see it, and it makes sense. It's like what? Ay. Okay. I gotta make sure.
I got the answer.
I mean, I'm looking right at it, and I still don't see. uh. Oh wait, I forgot I got rid of these variables. Maybe that's why. Let's see if that. Oh, left and right. Ay ay ay. Great, but now I don't have the original function, so I don't know what to tell you. Okay. But what actually solved it? I changed it so much, I don't know what actually solved the problem. Unmute yourself! uh, what's the unmute button? Control D. Oh, there you go.
Hear me?
Yes.
Okay, I still have our solution, which is partially wrong, not completely wrong. And I got another solution, which is right. And I gonna show it. Then compared to our solution, then we gonna go explain why ours wrong and there is right. Sounds good?
Sure.
Oh, you have your solution?
I edited stuff around and got rid of the variables. I'm not sure which part solved it, but
Is it
yeah,
passing?
it's passing.
I'll go expert.
Yes.
Okay, then we just use your solution. I don't need to use the one I researched.
I want to see the one you researched. Is it different?
You need to give me 5 minutes to type because it didn't show the code. I need to type in my text editor.
Uh,
So
I don't,
5 minutes. If you give me 5 minutes, I gonna get to the solution.
okay, I just pasted my solution into code, I guess.
2 hours?
Or into the VS Code.
Okay, where? But did you keep our wrong code? We still need our wrong code.
I don't the wrong code is still in VS Code. I left that, but I couldn't.
Okay.
So
Can
it's
you
technically still the code, but I changed it a lot. So
Okay, that's fine. I'm gonna share my screen, okay?
okay.
I'm gonna share my screen. Can you see my screen?
Yes.
Okay, so you are in line 75.
Uh yeah.
So this is your solution, right? I'm gonna go around to see if it's passing or not. Geez, you just put your name. It's like Jennifer's solution always wrong and
No. I don't
and
cuz I
saying
changed it, but I don't know cuz I was like it should like I figured it might be wrong, but I thought it would only need a couple changes and then I just changed stuff around. And then once it started running, I'm like, "But wait, what was the change that fixed
no,
it?"
your test case are passing. Nice, 11 test cases are passing.
But I don't know what was the actual fix. I just fixed a bunch of stuff.
Okay, let's compare. No worry, we're gonna compare.
So that was the only thing. Like,
Okay, yours is 75, right? Okay, we're gonna compare because I still got my, okay, we don't need that. We don't need the vast sorted. Are you looking at my screen?
yes, I'm looking at your
Oh,
screen.
now line turning and the right panel is yours.
Oh, cool.
Da, da, da. So left is mine, right is yours. Okay, we got 2370.
Don't
That
for,
is right.
so don't forget the array dot length instead of sort dot length
Which one?
for the for loop. Where are you?
It's line 80, mine is line
Yeah,
20.
because since you got rid of the variable, yeah.
Yeah, sort. Yeah, that doesn't make it like sort and array also it's the same thing, you know. Uh,
Yeah.
okay, left
You can leave the
point
variables because I don't think that was it.
current. Okay, hold on a second. Let me change. Okay. I'm gonna change all those stuff.
Um, because
Okay, we're gonna see left right point minus one. Okay, so we're gonna see while left pointer less than right pointer. Okay, let current sum equals array I. Yeah, that my current sum is array IP, right?
so my first guess was because and this gets into more about how JavaScript works. Uh,
Mm-hmm.
so once we have left pointer, right pointer, left num, right num. So it basically stores. It doesn't store the reference. It stores the value. So
Which
for
line you talking about?
go back to where we declare the variables.
Mm-hmm.
Yeah, you see, all this stuff here.
Yeah.
So in JavaScript, when we these because they're static values,
Mm-hmm.
it's only going to store the value. It's not going to store the reference. So when we put um, right pointer plus plus, it's going to when we run right pointer minus minus or left pointer plus plus, it is going to change these numbers,
Mm-hmm.
but the value of left num and right num still stays the same because it was already computed.
Okay.
So when these values update, these two variables stay the same, and and that's why I think they were getting counted twice.
Oh.
It doesn't recalculate array I plus one. It just keeps the same value.
What's the concept of that?
Um, it's just how JavaScript handles data for static values. Because for variables like this, it's easier to store the value, and when we store left num or right num, it's just going to store the value. It's not going to store the reference to array I plus one. It's going to calculate what that is and save the number.
Okay, I'm gonna comment out this. Okay. I think the only difference between your code and my code is you just make it when it's equal first.
Um, and well, first of all, I
Why
define
you
it as equal period because the other code doesn't, and I was interested in seeing how it runs when you don't automatically explicitly compare if they're equal, and it doesn't matter order wise. It doesn't matter. It should be declared just because you don't know what answer you're gonna get. You can get some weird not a number value, and then it'll um, it'll interpret. Oh, also, oh
sorry,
yeah. So the
what
reason you want to put it in the if statement is because even if one of those is false, it'll still run the code at the bottom. So where it runs like triplet dot push and everything, because it's not in a conditional, even
mhm.
even if one of these is true, it's still going to run everything here. If that makes,
Mm,
do you understand?
can you I don't understand. Can you explain from line 37?
So okay, well first we're gonna start with line.
M first, not less first.
So wait, what am I starting with? I'm starting with line 37, right? With the while loop.
First, my line 37 is yours.
Yeah. Okay.
No, 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 line 37, I understand. Sorry. Line 44.
Okay.
My line 44 is your line 85. Your line 85 is here. Why you need to do equal first? And I do less than my code is wrong and cause duplicate the triplets.
I just like doing the equal first. You don't have to. And my I have no problem just moving it to the bottom. Well, not like that. Nah. Like that's not the issue. At least with your code. With your code, it's not in a conditional at all. So let's say if current sum is less than target sum, this was true. Then we run
Yeah,
left pointer plus plus, and
yeah.
then we run this. This is false. Great, minus minus. This is
Uh-huh.
not. This is not under any kind of condition. So this will run no matter what. This will basically run every time.
Oh, got it. Cause I was trying to skip equal cause I would tell me do that and I say okay we already have less and greater than then the third scenario will be equal then. Now
Yeah.
I got it. We need to still write that one, right?
Yes. Because otherwise it'll just run every time. You could maybe skip one of the other ones as an else. Well,
Mm-hmm.
not as a or as an else, but yeah, all of these have to run based on a certain condition. None of these things run every single time.
Okay, so the tips for whoever watching this YouTube, don't be lazy about typing.
No, never be lazy, because your future self will love you for it, because you're usually going to be the one who has to change it later.
Just wanna type less one line, then you end up arrows, you know.
And you want to be able to read it, because like that's a you want self-documenting code. So like for the people watching this YouTube, if all they see is the end, they want to be able to read it and see what's going on. Otherwise, and writing extra lines, even though you don't need to, usually adds to it being read better, being easier to
Yeah.
read.
Okay. So I gonna change.
And also, the easier it is to read, the easier it is to explain to the interviewer, like, yeah, this is what I meant to do, versus, are you sure that works?
No, I gonna run for my modified version,
So the modified one
like
should
yours.
work.
So the logic is right. At least we found a bug, you know.
I'm pretty sure those two things are probably what makes the biggest difference. This,
Okay. Oh,
no, what's missing still?
oh,
Current
current
num
number.
is not defined. Okay, well there's that also. Yeah, you gotta change the plus and the.
I gonna log current num.
Where's current num?
Define.
Oh,
Oh,
so yeah, we got rid of the current num and yeah, because we commented those out. So replace current num with array I.
oh, yeah, yeah, yeah. This shouldn't be comment out.
Oh yeah,
Okay,
actually that one can stay. Yeah, the left num and right num no, but the current num is fine. That should be
okay.
fine.
I gonna do that one. So at least we prove the logic is all correct. If
Yes.
I mistype conditional check.
Yeah, I forgot about that. What is it still?
Left num is not defined.
Oh, change the. If you, I thought we changed all of left num. Okay, so
Left,
left.
okay, some I didn't change. So
So current
maybe
num can stay, but left num has to be array left
uh,
pointer.
I guess I will still have error because my right num is not changed either, you
Yeah.
know. I will be array at left pointer, right? Then
Yes.
array,
An array
uh,
right pointer.
array right pointer. Okay, this time should be all correct. Oh, got it. Small arrow. Okay.
There we go.
Yay! Nothing. Yeah. So now I got it. You write conditional check. Don't skip any. Unless you put greater equal than less than or less or equal than greater than. But if you cannot be, I already did the greater than and the less than, then you don't want to do the equal.
Yeah, so the order doesn't matter in this case. If you like to check for the answer first, if you check for the answer last, it should work. Whether it's if else or all three ifs, it doesn't matter in that case really either. Um, so yeah, that was the issue. We had too many variables, which can happen. It's possible, and then things didn't get updated properly.
Yeah. Should we explain the big O very quick?
Yes, let's do that.
Oh, today we are over time so much.
Yeah, we're over time. I know.
Map out like very clear.
Exactly.
Yeah.
If only for us, we got.
Okay, can you explain big O very quick?
So, the big O is O(n) squared. It's because that's the worst case. Worst case is O(n) squared. We loop over because we have nested loops. Now, granted, every time we run the for loop, our while loop does get smaller, but we are also doing multiple comparisons in the while loop because we have two pointers. So even though our loop gets smaller, we're still comparing numbers multiple times and moving each one by one. That's not the best explanation, but basically we're still comparing things worst case the same number of times, even though our while loop gets smaller because we have multiple, because we have double the comparisons in each while loop. So,
Oh, can you please change the big O explain no
oh right,
line for?
what line? Big O explain.
Yeah,
So
that was last time. Just modify it
okay,
to yeah
okay, so
104. Yeah.
okay, so that's wow. Where's my caret? Okay, O(n) squared. Uh, all right. Well, sort time stays the same. That's fine. But it gets omitted. But O(n) log n doesn't really matter anyway. So uh, we have for loop time, which is O of n or O of n. I'm not gonna do these math equations every time. And then inside of that, I guess we'll just do that as inside of that. While loop is O(n), and it's O log n plus n, blah blah blah, squared. And then you round down, and it'd be O n. Yes. Yeah, so it's O(n) squared because it's nested for loops, and and because we have two pointers instead of one, even though the while loop, even though our loop gets smaller, even though our while loop gets smaller each time, we have to compare everything to two pointers, so it stays O(n) squared, and then the space complexity is actually O of n, and that is I'm trying to remember the reason why. So I looked that up, and it's It's not because of the variables. It's I believe it's because of the inner loop. I forget why it's. Oh man, that's the worst part. I don't remember why.
Space complexity. Um, let me see. Space. Oh, oh, because we store every single number. Um,
Ah, okay.
because we do while loop. Um, for left and left pointer and the right pointer.
Yes. So every number eventually gets stored in as a pointer, or
Store where?
so you're saying because every number gets stored as a pointer at one point, we need O n space complexity. Okay. Okay.
Is it right? I don't. I'm not really sure.
You're the one who took notes.
Yeah,
If I
I
can,
think I half line, like the other half is missing.
I'm gonna have to. I'm not even gonna edit this. That's the worst part. It's just gonna stay wrong. Uh, so O of n because we have to store each element in the array as a variable to compare against? Question mark? I don't know.
No, that is not true. Because if that's the if that's the case, then two num sum the space complexity is O1. Remember, two num
Yes.
sum. Okay, I think because it's 2D array, then we store every element in the empty declared triplet. Is it correct?
Uh, okay. Yes. Okay, sorry. It's gonna be O of n space because. Okay. Because worst case, we have the entirety of our array stored as triplets. So the worst case is our entire array is consists of triplets, and we have to store the entire array in our triplets variable. Does that make sense?
Yeah, I think
No.
so.
So basically
Because
saying we have to while we're running the loops, we have to keep
look,
track of all the triplets, and the worst case is every number in our array can
you know
also be
the
stored as a triplet.
the triplets is more like to create a hash table scenario, right? So
We
when you do hash table, base complexity is O(n), you
when it's a
know.
hash table, yeah, and we're not using a hash table, which is true, but
Yeah,
but our function is storing the triplets array.
right. Yeah, that is my understanding.
So
So it's
like in our
very
example, we have in the base example they give, we stored 3 arrays. our
yeah,
our array is only 8 numbers, but we have 3 arrays, consisting of 9 numbers total. So the worst case would be about O of n if you have to store like the length of our array.
Yeah, that
Or some
makes sense.
version of that. Or some version of the array. If it's every single number, it could be. It's not going to be squared. That's close to impossible. But, we may store every set of numbers, in our array. And it could be two. It could be n. It could be 2n. It can be 3n. Absolute worst case. But that's still O of n space complexity.
Yeah. Okay, sounds pretty good. I gonna zip the notes and give you guys, cause this is YouTube video now. So I would encourage whoever watch this YouTube video, please like Davian and give like, well, hit the like button, right?
Yeah.
Smash the. Okay, I'm gonna start doing this. We will continue work through the thought process. Doesn't matter how much error we have, but we will work it through. And also another summary is the logic is all correct. It's just me forgot to put a conditional check, which is current sum equal to target sum scenario. I forgot to put that line in the conditional check. The rest are all good. So smash the like button, smash the subscribe button. Okay.
Oh, please, I don't do it for the likes, but if you really do enjoy this video, please smash the like button. Do what Jennifer tells you. She's the smartest woman on this call. Smartest person on this call. So please listen to her and smash the like button. Like and
So
subscribe.
to be a driver, even I don't have driving license. But
Excellent
I
driver.
have the guts to try. So smash the like button.
Or else.
Uh,
No, just
I will do better.
promise we
Uh,
will. I'll have more time to dedicate to these. It's going to be a lot better.
yeah. Okay. So should we end this now today?
Yes, let's end it. It was great.
Okay. Thanks, David.
Thank
You
you.
ran very well. Yeah.
Yep.
Okay, I'm gonna stop the call now.
And I'm going to stop the recording now.
Bye.
Bye. Probably too many fries, but I'll cool it. The pulse already cotton.